All right, so welcome to week 3 of the Clay 3D printing class. This week we are venturing back into step 1 over here. So we're back in the world of how do we create models in the first place. We already did this in week 1 with Fusion, Autodesk Fusion. So this week we're actually going to look at kind of a whole different philosophy of how to create 3D models using a different program called Blender. So unlike Fusion, which was born out of the world of Autodesk and AutoCAD, which is really for making precise parts, machine parts or houses or drawings for factories, Blender was born out of the digital animation world. So these are things like, how do I create 3D models that look like T-Rexes to chase Jeeps that are running away from them in the jungle? So the philosophy there is a lot different in that, unlike in Fusion, where everything you do has an exacting measurement with angles and relationships, Blender is way more of a, if it looks the way you want it to look, then you've done it the right way. So when you are approaching this, you really need to turn your brain around from Fusion, because I know you're going to ask questions like, well, what if I want this to be 0.25 millimeters, and I want this to be 3 inches, and it needs to be exactly 1.25 inches high? Maybe Blender is not the place you want to be for those kinds of models. But Blender gives you a lot more options for being way more organic in how you deal with the models themselves. Because it's not trying to calculate everything from equations, you have a lot more freedom to just grab parts of models and squish them around, and Blender is fine with it. The flip side of that is, because of the way that Blender works with models, it takes a lot more computing resources to have the same model in Blender than it does in Fusion. Because Fusion only has to store the equations that make up your parts, which in the computing space, that's not that much space to worry about. However, in Blender, the way Blender is dealing with this is it is actually keeping track of every vertex of your model, every point that makes it up, and how it connects to every other vertex. So once as you start going beyond things like a cube into more and more complex shape, this easily gets to, millions of points, thousands of edges, thousands of faces, and you can very easily take even powerful computers and crash them. I almost guarantee at least one of you will crash Blender working through these exercises without trying. I have crashed my desktop computer at home, which has 128 gigabytes of RAM, 16 cores. It has come to its knees because of Blender. So just know that with the freedom to manipulate these things, if you are asking too much of it, it will push you back. The reason I say that is because one of the big philosophies of Blender is that you want to make your shapes as simple as you can until you have no other choice than making them more complicated. That way you can get all of the structure and all of the basic design of your shape done. And then when you want to start making more complexity, you're working on smaller areas that won't just crash the whole thing. I'm not going to make a cube that has 50,000 points on it, because I know that just moving around a cube with 50,000 points is going to slow my computer down and it's going to be annoying to deal with. I might keep it with its 8 points, or I might make it out of 32 points, because maybe I want to make it into something slightly more complicated than a cube. But then it's only at the end when I want to say, okay, well, I want to have this face stuck on the side of the cube. That's when I'll take just that one section and start adding more to it.
So what if you have a ball and it wants to see all the tangents? What do? You only select certain of them?
Yeah, we'll see it. So you in Blender, rather than in Fusion, you as the modeler, the artist here, will be working directly with the points and the edges. So unlike Fusion, which sometimes feels kind of like a logic puzzle of like, how do I make the relationship of this square and this curve rotating halfway to like meet the line? If you want a line, you can just click a bunch of points and drag them to where you want them to be, and then connect them up. But again, because it has to keep track of that, there's no equation that defines that. the more points you make, the harder it will be to deal with. So we'll get there. The other thing that makes Blender a little trickier is that because this was created from a community of people, this was created in response to extremely expensive commercial software that does this. So things like Maya and ZBrush. Back in the 1990s, when Blender was first getting off of the ground, these were pieces of software that cost creators tens, if not hundreds of thousands of dollars. And there was a pushback from the artistic community to say, hey, I don't want to have to work for Disney to be able to afford tools that do this kind of thing. And so as Linux was coming onto the scene in response to like, I don't want to have to pay thousands of dollars for a Unix computer or deal with Windows, this also kind of came along with this in the mid-90s saying, hey, we know this software, we're just going to make it for ourselves. And so there's thousands of people who have contributed to make Blender what it is now. So what that means is there's thousands of people who wanted Blender to do their one particular thing, added in the code for it, and are happy that that feature works. Times 25 years of development means that Blender can do a lot of things very well. But because it's based on people volunteering to work on it, it is not necessarily the smoothest experience compared to something like Autodesk, who has engineers who their entire purpose is to make it easy to use. That's not as fun as adding new features, so Blender kind of lags behind in that respect. Not to say that it is hard to use, but there are a million buttons here. Like I said, this, don't be intimidated, but that's why this has to be on ledger paper. But we're not going to do all of them. We're going to take a nice, soft approach to the things that we can do in Blender to make models without having to think about equations or joinings or revolutions or whatever else. So let's all open Blender. You should have a screen that looks something like this. Liz, you're going to be a little bit different because you're on the older one, but I think all of this will still apply. The keys might be a little bit different, but so we're going to say that under this menu, we just want to say General for New File, which is just going to keep it the way that it looks right now. And you'll notice we're all staring at a cube in the middle of a scene. A scene is what Blender calls the collection of objects that you're dealing with. You'll notice that there's some other things in this scene, like a camera and a light. Again, that is because Blender assumes that you want to do 3D animation. We are not doing that. We're not going to deal with these things. So the first thing to look at is at the top right of your screen, you'll notice there's this drop-down menu, kind of like Fusion, which has all of the things that are in your scene listed. You can see our cube, you can see our light, you can see our camera. I'm going to click on the camera. I don't need it. And the hotkey for deleting things in Blender is not delete, which is what you think it would be. It is X. X for delete. You're crossing it out. That's how I remember it. And we can do the same thing for the light. We can click that in our collection list over here and hit X. So now we're just left with our cube.
Can we just not look at it?
You don't have to delete these if you don't want to, but I like getting rid of them because you might accidentally click on them and then get options for a camera that you don't understand because we're not talking about cameras. That's up to you. Yeah, you can completely ignore them if you don't want to delete them.
So you want everything except just cube?
We should have just a cube in the center of our screen right now. Now, up at the top left, you'll notice that there's a menu that says Object Mode right now. What Object Mode says is, I want to deal with all of the shapes that I've made as whole objects, regardless of how many points, edges, faces they are. When I click on one, I just want to select everything that it is. So notice when I click the cube, the whole cube is outlined. So that means that when I'm moving these shapes around, or I'm scaling them, or I'm rotating them, it is working on them as whole objects. So let's talk a little bit about what we can do to just move this cube around. So in your cheat sheet here, if you want to see the parts that because I'm going to say a bunch of hotkeys, there are probably menus for how to activate them, but you will be using all of these enough that it is, if you're going to stick with Blender, it's good to start getting these in your head. Most of them make sense if you're using mnemonics that are close enough. So we're in this red section kind of in the center left that says manipulate. That's what we're going to start with. The first thing is we want to just move this cube around in the space that it's in. That is the G key. So if I want to move this cube around, I can hit G on my keyboard, and you'll notice it's white, and now I can drag it around. Now by default, Blender will move things in a plane that is parallel to how you're looking at the object. So right now, when I move this around, it's kind of moving around in this like diagonal plane in between the X and Y. If you end up moving something and you didn't want to do it, and it's still highlighted, so you've hit G, but you haven't clicked or hit anything else on your keyboard, you can either hit Escape or the right-click button, and it will undo that action that you're attempting. Before I move on, I just also wanted to mention that up at the top right of your viewport here is this compass. This is very similar to what it looks like in Fusion. This is how we navigate our scene. So just like you have that cube in Fusion that tells you top, front, left, right, bottom, that's the same thing as we have up here. It's not quite as intuitive. Blender won't tell you top, but what it will tell you is the Z is currently pointed up, and that's the same thing as top, right? So just like in Fusion, I can click this compass and drag it around to rotate how I'm looking at things. The lines in this compass indicate the positive direction. So I can see that the positive Z, which is the upward direction, is currently pointed up in my scene. So that means that this part is the top of it, right? So if I were to rotate this compass, now you can see I'm looking at the bottom because the Z direction without the line is the one that I'm looking at right now. Liz has brought up something interesting. If you click on the actual axis, it will snap to that axis, just like clicking on top in Fusion would. So if you want to drag it around, you've got to click and hold to be able to drag it around. So we've talked about G for grab. That's how you move things around. G for grab is how I remember it. If you want to constrain this movement to one direction, so let's say I know I just want to move this cube upwards. I can, while I'm in grab, so I've hit G, I can then hit the axis that I want to constrain it to. So if I hit G and then Z, you'll notice that the Z axis has gotten highlighted, and now it will lock that move to just that axis. And then if you click, it will accept that action. Even if you've accepted an action, Blender has undo history, just like most programs. So even if you've left-clicked, you don't like how this moved, you can hit Command-Z or Control-Z, and it will put it back to where it was. The next one that we're going to talk about is scale. So S for scale. Scale is how you make an object bigger or smaller in Blender. So if I hit S, it will scale by default in all of the axes. So literally just make something bigger or smaller. Just like grab, I can tell Blender that I want to constrain the scale to one axis. So I can hit S, and then I can hit Z, and now I can grow or shrink this cube just on the Z axis to make a rectangle, or a rectangular prism.
Is there any sort of native scale to this? Is this just all visual?
You have hit a very critical part about how two paradigms of thought work when approaching Blender. This argument rages today about how to think about how to model things in here, especially for 3D printing. Blender is set up for computer animation. So all of its default shapes, when you go and add in a cube or you add in a cylinder, you add in a sphere, they will all come in at basically human scale. So everything comes in as a 1 meter object, a 1 meter cube, a 1 meter sphere, a 1 meter cylinder. You can make these parts close to dimensional to what you want to print them on and scale everything down to 100 millimeters or 10 millimeters. However, that means you're having to scale every one of Blender's default objects. The way that I like to use Blender, and some people like to use Blender, is that I will not worry about the absolute scale of what I'm making here. I'm just going to make the shape the way that I want it to look in relation to itself and not worry about the fact that it might be a 10-meter sized object. Then when I export it as an STL and bring it into the slicer, I'll use the slicer and scale it down at 10% or 5% or whatever it needs to be the dimensions that I want it to be when I actually print it. I think that's an easier way to deal with Blender, but it does mean that you have to wrap your brain around the fact that even though I'm building a 10-meter object, it's not actually going to be that big when I print it. Again, it kind of goes back to that philosophy that if you're working in Blender, just make something that feels good, and it's probably fine. And then, like we talked about last time, use the slicer to do those kinds of things because it will be better at that anyway.
So you mentioned that you would be in scale, and then you would hit Z, and you'd essentially be extruding a rectangle.
You're not extruding it, and that's an important point. We'll get to what extrude means.
Okay, so it's a different word.
It is, yes. Scale will not put any extra vertices in this cube. So even though I've scaled it, this cube is now, very clearly not a cube. It still only has 8 points and whatever, how many edges and 6 faces. Extrude does something different that we'll get to that's in a different part of Blender that's not in the object mode. It is the mode that when we want to work with individual vertexes and edges that will be in there when we're using extrude. One of the other things that you will probably ask me at some point is, okay, so I can scale the whole thing, and I know that I can scale by one axis, right? But what if I want to scale it on everything but the z-axis? I want to make it wider and longer, but not taller. Well, just like you can hit Z to scale on only the z-axis, you can hit Shift-Z to scale on everything but the z-axis. And so now it will get wider and longer, but it won't get taller. The last one we're going to look at for Blender is rotate. So R for rotate. And just like grab, rotate by default will rotate around a plane that is parallel to how you're looking at the object. Right? So if I hit rotate and I drag my mouse, it will rotate kind of on this weird diagonal. Just like all of these other manipulation commands, if I want to rotate it around the z-axis, I can hit Z and it'll rotate around the z-axis. If I want to rotate it around X, I can do that. If I want to rotate around Y, I can do that. All right, so that is kind of all we need to know right now about object mode, is how do I move an object as a whole? The next thing I want to dive into is, okay, well, what if I want to manipulate this cube so it's no longer a cube? The way we do that is up in the top left, you'll see that if you click on object mode, there's some other modes that we can put Blender in. We're going to talk about edit mode a lot, and we're going to talk about sculpt mode briefly. The other things have to do with functions about like colors and textures of objects, which we don't need in order to print them, because the clay is the color that it is. So we're going to go to edit mode in this menu instead of object mode. There is a hotkey for this as well, and that's tab. So if you hit tab, it will quickly switch between edit mode and object mode, because this is something that you will do a lot, is that you'll move something, want to make it a slightly different shape, go into edit mode, make it a different shape, go back into object mode, drag it up next to a different object, figure out that it's not the shape you wanted it to be, go back into edit mode, et cetera, et cetera. So that's why it's on tab. That's just another quick thing to go back and forth. And you'll notice that unlike in object mode, it's given us a little bit more as part of what we've highlighted. Right? So now we can see that there's dots for the points that make up the cube. There's lines for the edges that make up the cube. And there's kind of like orangey faces for the faces that make up the cube. If I click somewhere that's not on the cube, it will deselect everything. Now up near the edit mode, you'll see there's these 3 kind of cube representations. The first one means that when I select things, I will be selecting it by the vertices, the points that make up the cube. So if I click on something, it's going to select the point that is closest to where I clicked on the cube. The second icon over says when I select things, I want to select them by edge. So now if I click, you can see it's the edge that shows up. And finally, the last one, you can probably guess, that's to select by face. So now if I click it, it will select by face. And if I rotate this cube, I can select other faces. This is because the way you change your shape might be dependent on how you're selecting things on your shape. For example, maybe I want to make this cube have this point be slightly askew. So I can go into this vertex select mode, click this point, hit G for grab, just like in object mode, and now I can drag this out. And now I've made a new shape that has a weird point on it. We have already gone past what would be easy to do in Fusion. Making this shape in Fusion would take more steps than what we just did in Blender, which is why Blender is useful sometimes. Like I said, it's easier to make organic shapes here than it is in Fusion, in my opinion. So yeah, we can take individual points, or if you hit Shift and you want to move multiple points, you can do that too. So if I hit Shift and select both of these, now if I use the grab tool, I can move both of those points together and make an even more interesting shape. Just like in object mode, if I know that I want these points to move just on the Z direction, I can hit G and then Z, and now it will move these 2 points just in the Z direction, or X or Y. Right? So all of the manipulate tools work the same in object mode, or in edit mode as they do in object mode. Now, of course, I have these 2 vertices selected. I could do the same thing by being in edge select mode, selecting this edge and hitting grab. That's going to do the same thing. Or if I wanted to do it by face, I could do that too. I could be in face select mode and then hit grab and move this whole entire face around. And there are shortcuts to go between vertex mode, edge mode, and face mode. If you're in edit mode, you can use 1, 2, and 3 to select between whether you're selecting by points, selecting by edges, or selecting by faces. Again, those are very quick keys because you'll be switching between those quite a bit. So the next thing I want to show you is that Blender is actually smart enough to do more organic manipulation based on how close points are to the point that you're moving. So up here, kind of near the middle of your viewport, you'll see there's this like dotted circle next to what looks like a bell curve. That's called proportional editing if you mouse over it. And if you turn it on, what that says is, hey, Blender, when I move something, I want you to move the points, edges, or faces that are around that in proportion to how I'm moving that point. So now I have proportional editing mode on that's highlighted. So if I take this point now and hit the grab tool, you'll notice that there's an extra thing that appears. We have this little circle that pops up, and that is the influence of the proportional editing. If you use your mouse wheel, you can spin that open or closed, and that will increase the influence of how that moves around. So now if I open this up, you can see it is moving more than just the point that I'm moving around based on how big this circle is.
The circle doesn't move around, I noticed.
No, the circle is based on where the point originally was, but it's just there to indicate how much influence that proportional editing is going to have when you're moving points around. And this can get really cool when you're dealing with objects that you may have originally created in Fusion and want to kind of make it a little of a skew. Because then you can select a part of it, turn on proportional editing, and nudge it or tweak it just a little bit and have the piece organically follow that change around that you've made. So you don't end up with just like one row of your shape rotated. It will gently rotate everything with it.
How did the circle appear again?
So if you have proportional editing on and you go to use one of the manipulation tools, so for example, grab or rotate. So right, rotating a point doesn't make sense, but if I go and select this edge, right, I can still say rotate and rotate this, right? So if I turn up the proportion, it's going to start rotating all the other points around it.
Okay, keep rotating until it's gear shaped. Is
Yeah.
that what Blender will crash when you do stuff?
It's
like
not
that?
going to crash. It still knows where it is. And just like Fusion, Blender is trying its best to keep this a realistic model. But unlike Fusion, which at some point will just give you a red X and say, like, you've gone too far, I can't do this, Blender will still represent things that cannot physically exist in real life. And you'll see that as like the shading starts to break, like this is Blender saying like, hey, you've twisted this such that like there are faces going through each other, and I don't know how to represent that, but I'm gonna do what I can. There's a tool that I'm gonna show you a little bit later on that will check for this kind of stuff called the 3D printing toolbox. It's built into Blender, we just have to turn it on, that will have checks to say, do you have faces that intersect? Do you have things that have zero length? Do you have parts that aren't actually closed all the way? And it will help you, it won't fix them, but it will show you the things that need to be fixed. So we've been playing a lot with this cube, but you're probably saying, well, a cube is kind of boring, right? So how do we start making something that's more than just a cube? And that's going to get into the actual modeling command. So this is where we actually get to start adding geometry. When you are in edit mode, I like to start in face, and you have a face selected. You can hit E, which will extrude a face, which will create new geometry by default how that face is pointed, right? So you can see when I hit E, it's creating new geometry that is coming out from however that face got constructed. So now it is no longer a cube, right? Blender has added more points to this shape that gives you more geometry to play with. Yeah, so all of this is going to happen in edit mode. Edit mode is what I want to do things that are affecting the individual points, edges, and faces on an object. Object mode is for moving this thing around in space on its own.
It looks like if you do it twice in the same direction, it just keeps adding.
That's right. Yep, and this is how you can build up pretty complex shapes, is you can start extruding something and then extruding away from that face. And now extruding, maybe I want to take this and then extrude it in or out. But see, you have to be careful in Blender, right? Because notice what I just did. Let me get this. I took this face and I extruded it out. Blender is not really going to care that this is broken. This is not a printable shape because now we have a face that's going through another face. This is not a solid like it would be in Fusion. So I'm going to go into this box itself just so you can see what I mean. So we're entering the interior of this thing. It's actually hollow, and these faces are really screwed up. So you have to be careful about creating geometry that intersects itself in Blender.
Too bad it doesn't tell you.
The 3D printing toolbox that we'll take a look at will tell you. In fact, let's all turn that on now, just so we can see what that interface looks like. So if we go up to the top into the Edit menu, and then into the Preferences, there are a lot of things that we can change about Blender. I'm going to have you change 2 things while we're in this menu. The first thing that we're going to change is we're going to go into Key Map. And in Key Map, there's going to be an option for spacebar action. Right now, it's set to play, which is not useful to us because that's really only for animation, and we're not doing animation. We want to set the spacebar action to search. And what this does is it tells Blender, hey, I'm new to Blender. I don't remember all of, all of these hotkeys. I just want to be able to type in extrude and have extrude happen. So now when you hit spacebar, it just gives you a search menu that you can start typing in extrude, and then it will give you that command. So if you don't remember what all of these are, now you can just hit spacebar and search for it.
Oh, you can literally type out.
Mm-hmm. And I still use this a lot, because I don't remember all of these hotkeys, especially for some of the ones that I only use every once in a while. So it's really useful to just have that map to the spacebar. You can just hit it, start typing what you want, and 95% of the time it will be there. All right, so now let's turn on this 3D printing toolbox. So we're going to go over to the add-on section on the left. And that's going to give you, these are all of the things that are built into Blender, but are like 4 specific ways that you might want to use Blender. So the Blender team turns them off just to make Blender not even more overwhelming than it already is. And so in the search bar, we're going to type in print, and it will come up with 3D print toolbox. And we're going to check the box next to that to turn it on. Next to the compass, there is a tiny little left-facing caret that we want to click. And that is going to give us access to all of these add-on features. And then that will pop out these new tabs. One of these new tabs is called 3D Print, which if we click is going to open up the tool that we just turned on. And this has a bunch of analysis tools to try to tell you when things are going wrong. So it'll tell you if you have edges that are less than this size, or edges that have more than 45 degrees of distortion, or are not thick enough, or are too pointy for the 3D printer to actually make a turn. But you can just hit check all, and it will do all of them. So now under here in results, it will tell you all of the things that might be going wrong in your 3D print. So like I said, this extrude now has faces going through each other. And in fact, this analysis has told us that. We have 5 intersecting faces. If we click that, it will highlight the ones that are intersecting to tell us that they're a problem. Right, so there's lots of ways that you could fix that, right? I could take this face and use the grab tool and move it away. And now if I run that analysis again, I don't have any intersecting faces.
There's no function to just kind of deal with it?
It wouldn't know, right? Because it doesn't know how do you want to solve it. The goal is zeros except for overhanging faces. Overhanging faces is a check that says, hey, I know that there are faces that are over 45 degrees, which is, again, kind of that limit of like, this won't print without supports. So if you click that one, you'll see it's just the ones on the bottom. So that's basically this tool saying like, hey, just so you know, if you print this shape in the orientation that you have it, you probably need support for these things. So you want all zeros except for this overhang faces, which is more of a warning than a danger.
How about non-flat faces?
Right.
Yeah, so non-flat faces is an interesting one, right? So let's try to make a non-flat face. So I'm going to take this vertex here, and I'm going to grab it and move it in this direction. And now I have a non-flat face, because look what happened. This thing that was a plane is now like bending in order to satisfy these 4 points.
So that's this area?
Well, if you click
In
it,
that case.
it will tell you what the non-flat faces are. So you can see that this is bending to satisfy how those points are. That may or may not be an issue when you print it. When you export as an STL, Blender will try its best to put in extra edges to make non-flat faces flat.
What's a 0 faces?
So zero faces mean that it's a face that has 0 area, which means that you made it and scaled it down all the way, or you did, and then like you hit extrude, didn't move it at all, and clicked, so now it is in exactly the same spot as another face. So it just means that you have a face that is geometry, but it's not doing anything for your model.
Add that connection, like.
That's what we're going to talk about. So the next thing that we're going to talk about is for these non-flat faces, or if you want to do this for your own reasons, you can add in edges by clicking on vertexes that exist. So if I go into vertex select mode, and then I hit the K for knife, knife creates new edges. And then I can click on one vertex and click on the next vertex, which is going to draw a purple line. That's where I currently have a new edge created. And then hit enter. It will create a new edge that has now allowed this face to be two flat faces. So again, if I hit check all to check again, that one's been solved. This other one right here hasn't. So now I can use the knife tool again and connect these two, hit enter, and now I have no flat faces. The knife tool, in addition to solving non-flat faces, also makes it so that you can extrude just parts of faces that you would want to extrude, right? So maybe I only want to extrude the bottom half of this current triangle that I've made. So I can use the knife tool, make a new edge here. So now when I go into face select mode, I can take just this part and extrude that.
When something like this is hidden, this face apparently is this, but it's hidden, right? That means it's hidden between these.
That's probably what's happening, yes.
So how do you solve something like that?
You might have to go inside your shape, like zoom all the way in, like this, find where it is, and then I'm going to do it on the outside so you can see it because I don't have any. Just like in object mode, if you hit X, it deletes things. You can hit X, and now it's going to ask you, what about this thing that I have selected do I want to delete? Do I want to delete the vertexes? Do I want to delete the edges? Do I want to delete the faces? Do I want to delete the edges and faces? Just the faces? That's deleting them. So let's see what that does, right? Let's just delete this face. Now I have the shape without a face here. All of the points and edges still exist, but it doesn't have a face here. And if I go into my 3D print toolbox here and check, it's going to say, hey, wait a minute, this is not an enclosed shape anymore. It's non-manifold. That means not an enclosed shape. If you click it, it will tell you these edges are why it is not manifold. So let's undo that. And let's look at a different way of deleting something. So if I hit X, you can also see there is a dissolved version of this. And this tells Blender, hey, don't just get rid of the face. Make it so that the model doesn't have this part of the geometry in it. It might not be able to do this on a face, actually. So I'm going to do it to the vertices. So now it not only deleted those vertices, but it collapsed everything down as if they were never there in the first place. And that dissolve is usually more useful on edges than it is on faces. So for example, if I didn't like that this edge right here is here, I can go into here, select it, delete, dissolve edge, and now that edge doesn't exist. Now this is probably going to be a non-flat edge, so I shouldn't have, but you can. And that's generally how I will use it, is that I'll see, just because of how I've been playing with the shape, there are more edges than I need, and I'll use that dissolve to get rid of at least some of them. So the next thing that I want to talk about is another modeling tool that works similarly to extrude, but instead of making new geometry out from how that face is facing, it makes geometry that is inset. So for example, if I take this shape right here, let me get it in a better orientation, and I hit I for inset and drag my mouse, it's going to create new geometry based on that face that is inset from that face. And you're going to say, why do I care about doing that? And the reason is that allows you to connect to geometry that then is either smaller or bigger than the geometry that you currently have. So now if I take grab, I can move this around, and it's going to make a nice, smooth connection to this size face. Right? So I'm going to keep moving this face out. So now I have this inset has allowed me to create kind of this pyramid shape.
Where is the inset?
Inset is the I button.
What about if you see another I button here?
It
Combination.
is probably part of a different mode that's not edit mode.
Okay.
Okay, I'm still in edit mode. I hit I. Oh, I guess I'm doing the wrong thing. I'm using my keyboard. This thing.
Everyone good on inset? Do you have questions? Got it?
Mine is really weird.
Weird is fine. Mine is also very weird. This is not maybe something that I want to print. We're just playing around with the tools that Blender gives you, right? Because really, what we're trying to get at, right, is once you have a shape that you like, you can now go back and grab, an edge here, and turn on some proportional editing, and now we can really start playing with it. We'll make it a little wonkier, and then we'll take this face here, and then we'll rotate that, right? So this is really good. This is the tools that you can use to really put some organic feel into the shapes that you have. And we'll get into another tool. Yeah, we'll get into another tool that helps make more rounded objects, more, blobular objects, for lack of a better word. So the next thing that I want to talk about is, I've been saying a lot, like this extrude command moves or creates a new face based on how the other face is facing, which is a weird way to say it. And the word that I actually want to use from now on is called the normal to that face. And you can think of the normal of a face as the direction that that face is trying to point in. There's a more mathematical definition of what a normal is, but there's actually a view, so you can just see them in Blender, so you don't have to worry about how you would think about these. Let's just look at them. So up in the very top right of our scene window here, we have a bunch of what looks like X-ray vision things. These are the ways that we can manipulate how objects are being displayed in our viewport. So for instance, if we want to see through our mesh as a wireframe, you can click that wireframe view, and now you can see all the way through it, which is another way, Uni, of being able to see if there's a face inside your shape is by looking through it like this.
I see the scene, but how do I get to its menu?
So we're
Or
up
is this-
here right now. So we
these?
clicked that wireframe thing.
This guy.
Yep. So the two that we're really going to be worried about is this wireframe one and the solid one next to it. The other two are for when you're doing animation and want to see what it would look like with lights and textures on it, which for us, because we deleted that light, is just going to be dark. That is not helpful to us. But the other ones, this wireframe one is useful. But next to that, you'll see that there's a square with a highlighted square in the top of it. This is where you can add more information to what is in the viewport. And the thing that we're interested in seeing right now is there's a section called normals. And there's 3 different buttons. The one that we want to click is the one that's the farthest right of these 3 buttons, where it looks like a line coming out from the center of a square. And then we're going to drag this size up until you see these kind of blue hairs on your object grow big enough to be noticeable. So notice how now each of my faces has these blue hairs. That is showing you what the normal direction of that face is. Or as I was saying before, this shows you the direction that that face is facing. And I like using this view because it really does give you an indication of like when I use the extrude command, like which way is it going to go. And it doesn't have to go this way. By default it will. But just like in object mode or when you're using the grab tool, if I hit Z again, it'll say, I'll just be able to move it wherever I want. Or do I want it to shift in the X direction based on how it's facing? Or the Y direction based on how it's facing? So just like the grab tool, the extrude tool can be moved around too. Now, another interesting thing is if you're already in Z for based on normal, if you hit Z again, it will make it so that it is Z of the whole scene, not the normal. So you can also extrude straight up and down, not based on the model, but based on the axes. And that can be useful.
So you always have that on?
I like having that on because one of the other issues that can happen with models that will screw up how they slice is that depending on how you've created this geometry, sometimes these faces will end up facing the wrong direction. So for instance, if I extrude this through here, you'll notice I don't have those hairs on the outside of my model. That's because these faces are actually facing in, which is something that I can look at if next to that like square menu with the one highlighted thing, there's the two circles menu. That's just another way of adding more information to the model. And in here, you can see geometry face orientation. That is telling you, that just gives you a color of which way are these faces facing. And maybe it's not obvious, but it's obvious to me. I would want all of the faces of my model to be facing outwards. So blue means all of your faces, or blue means that face is facing outwards. Red means your face is not facing outwards. That will cause issues when you're trying to slice it because the slicer is saying, well, wait a minute, this part is on the outside of my object, but this part is on the inside of my object. I don't know what to do with that. And I think that the 3D toolbox will tell you about these kinds of things, but mostly it will just end up as intersecting faces because it's hard to get flipped normals without that, but it can happen. So these are just tools to look at a model to see. If it starts slicing weird, start turning on some of these features just to check if there's something weird that you didn't notice. I don't normally work with this on because I think the colors are pretty distracting, but again, if you see things starting to go wrong with your model, it's a good check. I'm going to undo what I did to that face so that I don't have any flip normals. So the next thing I want to do is, what do I do when I already have an STL that maybe I made in Fusion, maybe I found it on the internet, but I want to take it into Blender and do some stuff to it. I want to mess with it. I'm going to go to a website that I like for getting pre-made STLs, but you could take an STL that you've made in Fusion and exported. That's fine. I like the website Printables. Printables has a lot of 3D printable shapes that people in the community have made. A lot of these are for plastic. Almost all of these are for plastic, but if you can print it in plastic, you can probably print it in clay. So just off the cuff, I'm just going to say like cat. There we go. So here's a bunch of different potential cat models that we might be able to print in clay. So don't think that you have to model everything. People have modeled a lot of things. Just because they're on this website does not mean they're printable. This is a community website. People put lots of weird things in here. In general, if you see something has a lot of hearts, it's probably printable because people aren't going to like it if it's not printable on a website meant for printed objects. So let's take this long guy because he seems fun and is probably printable. And we'll hit download. It might ask you to sign up, but you don't have to. Like it already exists. So all right, we've downloaded this cat model, cat STL. I'm back in Blender. I'm going to go back to object mode, mostly because I don't want this weird globby shape that I've made So I'm going to highlight it over here. No more weird globby shape. Instead, I'm going to go into File, Import, STL. Don't do STL experimental, just do the normal one. I don't know why there's both of those. I'm going to go into my downloads, find the cat, hit import. It'll take a second. And here's our cat. Yeah, like I said, a lot of people will model in Blender just to make the shape that they want. This is a very large cat, but we can scale it down in Prusa. So yeah, here's our cat. Now I can go into edit mode, and we can see that it has a lot of vertexes. I'm going to turn off the normals view just so we don't see that. But you can see this is a fairly dense mesh, right? So this is a 17 megabyte mesh. This is probably doable by a normal computer, but we're getting to the point where you want to start being careful. But for instance, maybe this cat is long, but not long enough for my desires. So right, I'm going to take this head, I'm going to select it. Now notice I only selected the front face, because by default, it only selects what you see in the viewport. There's a way of selecting everything, and it is by using this 2 squares overlapping button that's called X-ray mode, and that allows you to see both the front and back of an object. And when I select it, it will select everything here. So now I have all of those. I have proportional editing on, so I know that the model is going to move as I move these. I'm going to grab, which might take a second because this is complicated. I'm going to grab in the Z direction, really turn up that proportion, and then I'm going to move this head up. So now I have a super long cat. Let's turn off X-ray mode. So now we can see, and go back to object mode, we can see now I have an even longer cat. That's what Blender makes really easy. Like doing this in Fusion is absurd. Like you don't want to do this kind of thing in Fusion. So does that make sense to everybody? Like maybe I will build something that I want to model that is easier in Fusion, like maybe doing arrays and stuff like that. I find that easier to do in Fusion. Export that out of Fusion as STL and then bring it into Blender to start making it askew and slightly asymmetrical and a little bit more artistic. There are additional tools that Blender has that does some of this stuff automatically that sometimes are interesting. So we'll leave this cat up. You have to be in object mode for this to work. I have made this mistake many times. Blender will allow you to put these things on your objects in edit mode, but you won't see the effects. So make sure you're in object mode if you're going to use these things. Over here on the right side, there are a bunch of properties about what our object is. So you can see by default, it's the transform. So this is saying we haven't moved it, we haven't rotated it, we haven't scaled it, it's where we left it. And there's a bunch of other information about it. Basically, every piece of information that exists is in here somewhere. But the thing that we're interested in is actually one tab down, which is this little wrench icon called modifiers. Modifiers lets you put algorithms, kind of like Fusion, onto your objects to do things to them without you having to move the shapes around themselves. Some of the more interesting modifiers for me are if you click Add Modifier in the Deform section. I like Simple Deform. And what this does is it will twist, bend, taper, or stretch your shape. So if I want to twist this cat in the Z direction by 360 degrees, I can make a very twisty cat. I don't know that this is printable anymore. It might be, but this is an easy way to just take something that is maybe a little boring in Fusion and twist it, or taper it, or bend it.
Are these proprietary or licensed in some way?
So if you are in printables, the license for these shapes are all at the bottom. So you can see how whoever created this is allowing it to be used. So this is under a Creative Commons Attribution license, which says you can use it any way you want to, but if you repost it, you need to give him credit.
Even after you altered it?
That is exactly what it is saying. You can remix it, you can sell it, you can put it in art displays. It is open, so you can modify it in the open source definition of open source. But if you are going to share this file, even the file you modified, you need to tell them, hey, this is based on a file that was originally created by Gustavo Renzendi. Not all of the things in printables will follow this license. This is a pretty common one. But you are required to have a license when you put things on printables that tells people how you would prefer them to use it. Typically, people are not going to put things on printables that are not at least somehow remixable. That's kind of the point of this site, is to have people be able to access this and do things with it. But yeah, just double check. But yeah, to answer your question, Liz, I can now print this and sell it at the art fair, and that is allowed. The interesting thing about the modifiers is because they're algorithm-based, they are not making any of their actual changes until you actually apply them. So notice, I can take this off, and the cat will go back to normal. This is important to know because it won't export as part of the STL you make in Blender until you apply those changes. So let me reapply the simple deform. Let's do a...
Where is apply?
I'll show you in just a second. Let's do a stretch. We'll do a stretch in the Y direction. So we'll have kind of a weird looking up cat. In the drop-down menu that is next to simple deform, we can use apply. Now that modifier has gone away because Blender has taken that algorithm and applied that change to all of the vertexes, the edges, the faces in this shape. If I go into edit mode, now they are where they are supposed to be. And I can continue to make changes from here, right? I can go back into X-ray mode, select the belly of this cat, grab it, which takes a second even on my computer, move this over. Maybe I don't want it to be this proportional. So now I have a bent and deformed cat. Go back into edit mode, select his head again, rotate his head this way, go back into object mode, really play around with these things. This is probably not printable. There's probably intersecting stuff. And this mesh is complicated, so you can see how long this stuff takes, which is why I say careful how much detail you put into stuff, because this computer has 32 gigs of RAM. It's an older computer, but it was fast, and you can see how long it's taking to do this. It might have crashed Blender, yeah. So I have crashed Blender. I guaranteed you one of us would. It was apparently me. So the easiest indication is that when I look at the size of this STL, it is 17 megabytes. It depends on your computer hardware how complicated this is. This is probably no problem for my desktop at home. This is a problem for my computer that's 6 years old. This is probably not a problem for the new Mac laptop you buy for $4,000. just Blender, more than probably any other program that I have used, is hardware dependent. And like I said earlier in one of the previous classes, 3D modeling is one of the reasons why if you do this in industry, you will be working on $20,000 computers, because you don't want to have to wait the 2 minutes it would take to analyze this or whatever. Your boss is gonna spend the money because he would rather you get through 10 models that day instead of 4. And it doesn't matter that the computer costs 20 grand because he can charge the client 50. So the last thing that I want to show you is, what if I want to take multiple objects and put them together? Because that's probably something you're going to want to do. So the way that you can add in basic objects in Blender is with Shift-A. Blender has normal shapes in here. So cubes, circles, some different kinds of spheres depending on how you want the geometry of that sphere to look, whether you want it to be like a bunch of rays coming out of a sphere or a bunch of triangles that approximate a sphere. You can do cylinders, you can do cones, you can do toruses. The monkey is a famous thing. That is one of the first things that was modeled in Blender, is this monkey head. So that's one of the objects that Blender will always allow you to add to scenes. Its name is Suzanne.
So you can just like put it on the chest of the cat.
Exactly. So let's take this monkey head. We'll scale it up. So I'm going to hit S. Scale it up. Right, now I'm going to go find where the cat head is for the most part. So I'm going to grab Z, move it up, grab Y, move it over, grab X, move it over. Right, so now we've got a monkey head that is on top of our cat. The problem is that these two things are still separate objects. If I were to export them as STLs, they would export as two STLs. There is an easy way to fix this in Blender, but it is only the first step that we have to do. So the first thing that we do is we can select both of them, right-click on them, and say Join, or you can hit Control-J. So now Blender has taken their geometries and put them together such that they are one object. However, it hasn't changed where their geometry is. So now there's a bunch of cat geometry that's inside the monkey geometry, and there's a bunch of monkey geometry that is inside the cat geometry. This won't be sliceable, this won't be printable, because there's a bunch of weird stuff going on. I'm not going to try to use the analysis because of how complicated this cat is, but trust me when I say that. There's one more step that we have to do in order to make this work, and that's to tell Blender, hey, take the general shape of this thing and redo the mesh so that it doesn't have these issues. I just want the outside of it, and I want you to give me your best approximation, Blender, of what you can do with this shape. That is a modifier. It is in the Generate tab, and it is called Remesh, surprisingly enough. So now you can see this is Blender's first attempt at doing this at a fairly low resolution. It's kind of messed it up, but we can take this voxel size, which is us saying, hey, use a smaller grid to remesh this shape. Just be careful, because turning this down too quickly will create a lot of geometry, and this is the single largest way that I have crashed Blender, is by clicking this 3 or 4 times before realizing, one click at a time, let it calculate, see if it's good enough for you, then go down again.
PrintableFusionPro.com?
Printable is made by the same company that makes Prusa Slicer. Prusa Slicer is one of the most popular 3D printing companies. When they were created by one guy in Czechoslovakia or Czech Republic or Czechia, depending on, I don't remember when he did it, but that country has been through a lot of names. In the early 2000s, it was really like made out of like hardware components, like things you get from the hardware store, like lead screws, nuts and bolts, like lots of wood cutouts. But his whole philosophy was, I am making this for everybody. I am not making it to be a company. And so he started selling basically kits of parts of like, hey, if you want to build this, here's the thing that I built mine out of, and here's the instructions on how I built it. And he built kind of a 3D printing empire from this idea of, I'm going to share everything that I have. All of the designs for every printer they make are all open source. You know exactly what parts they're using, how to put them together, what to cut them. However, at this point, they are making some of the best 3D printers in the world in terms of cost and ability. So he has not lost that philosophy, and that's one of the reasons he created this website is, hey, like, we've done a lot with hardware, but we're not experts on modeling. Let's make a website so people that are can also share their ideas with everybody. And that's how printables came to be. So you can see, like, this is now taking what used to be a very weird, messed up set of points and edges and whatever, and Blender is doing its best to try to give you a shape that approximates what it is. And so we can keep going down in this voxel until we get something that we are happy with. It will. So a voxel is like a pixel is a two-dimensional gridded display, right? Your monitor has pixels that are a length and a width. A voxel is the three-dimensional equivalent of a pixel, a volumetric pixel, voxel. So basically, you can see that there are different algorithms that the remesh can use in order to do this. It defaults to voxel, which says, Blender, I want you to check at every point in my model whether this size cube is on the inside or the outside of the model. And if it's on the inside, then put a cube there. And if it's on the outside, don't put a cube there. And rebuild the mesh that way. That's how you end up with this kind of blocky look, is because it is the voxels that are all now connected to each other. There are other algorithms you can use. Sometimes they're better, sometimes they're worse. Sometimes they crash. So this might be better or it might be worse for your purposes. It really depends on what shapes you're using. Clearly, this technique worked really good for the cat, not so much for the Suzanne. So here's it trying to approximate with as sharp as edges as it can. Again, the whole point of this is really to take those objects that we've joined together and get Blender to get rid of all of the issues with them so that we can print them. So that's kind of the last step. And I'll just go back to voxel for this purpose. And you can see, like, Suzanne was a pretty low poly object. So even with the voxel reach, you're still getting some of the distortions of her being made out of only a couple edges and faces and vertexes. You can. Again, as I'm adding more geometry, Blender is going to get slower and slower. Eventually, we're going to hit a point where it's going to take more time to calculate than my computer has memory. Because again, it's trying to keep track of all of these voxels in memory. You're creating more of those things, right? So if I apply this, which just like any other modifier, over here on this drop-down menu, apply, we can go back into edit mode and we'll see this new mesh that it created out of the voxels. So what has probably happened is this cat probably got simpler and this Suzanne got way more complex. We still have the weird ear of the cat poking through and whatever was going down with the chin of the cat in the back side here, because I didn't do a good job of lining these up. You can do a better job when we have more time. But now this is one shape that we know is manifold and we can print.
Can you, I don't know if this isn't a word, but sort of down-voxelate the Suzanne first?
Yeah.
And then
You can do that, yeah. In fact,
add it.
yes. In fact, there's a modifier that does that. So if we go into modifiers, and I think it's in deform, no, it's not in deform. It is in generate. There's a modifier called decimate. So decimate says, I have too many edges and faces, and Blender, I want you to algorithmically start removing them. And that's what this ratio does here. So ratio says, I have one. I have all of the edges that I started with. I can start to turn this down and say, OK, now my mesh has a third of the edges that it used to have. I can. Yes. In fact, I may have done that if I was thinking about it. So now I have a tenth the faces that I used to have. And you can see, now we're at 1% of the edges we've had, and it's created a very geometric cat. That's not necessarily a bad thing. This could be cool, right? Maybe I want to take something that's a very high resolution, realistic render of something, but I want to make it print geometrically, throw it into Blender, give it a really low decimate ratio. That's too much.
Oh my God.
Give it a really low decimate ratio and create that like cool geometric effect. So something you can do if you have these sliders and the changes you want to make are smaller than what it's making for you by default of just dragging the mouse. If you hold the shift key, your dragging will get 10%ed of what it used to be. So now I'm changing 1/10 what I used to be changing when I was dragging the slider. So this is a good way, now that we're at like the very lowest numbers, dragging very slowly to try to figure out how close can we get. So that's probably as close as I would go before it stops being a shape. But I mean, it still looks kind of like what we had. So decimate is fun. There's a lot of these other modifiers. They're fun to play with. So go through and There's lots of YouTube videos, I can't go through all of these, that will walk through what each and every one of these do. But that is kind of my basic process of what I would do in Blender most of the time for 3D printing. So taking an object, probably from Fusion or maybe from printables, putting it in here, using the manipulation commands to drag around edges and vertexes to deform it into more interesting shapes, maybe putting 2 or 3 or 4 objects together, using join to do things like putting monkey heads on cats, and then, yeah, doing that remesh step so that we know that it is one continuous mesh. And then, yeah, this gets exported just like everything else into the slicer. So let's do that just as the last step here.
So what happens when it crashes? It just shuts down?
Yeah, so that is something that I haven't done, and I am a bad person for not doing this. Save early and save often. Unlike Fusion, not only does Blender have a much higher chance of crashing because it doesn't have some of the safeguards that Autodesk, I'm sure, has worked hard to make sure Fusion doesn't crash. It also doesn't have the parametric design philosophy that Fusion has. Unlike Fusion, where it has that timeline on the bottom where you can say like, oh, well, this thing that I did 45 minutes ago, I didn't actually like how I did that. I want to edit that part, but keep everything else. Blender can't do that. Blender has an undo history, but if you undo to that point 45 minutes ago, you've undone everything that you've done up until 45 minutes ago. So if you are at a point where you're like, ooh, this is a cool like middle ground, like I like where I'm going with this, save that so that if you mess it up, you have a point to go back to. So yeah, save early, save often. But let's say I am happy with this, now I want to take it over to the printer. This is very similar to what we did in Fusion. I'm going to select the object that I want to export, File, Export, STL. So we'll put it in my Blender projects. This will be monkey cat, export STL. So now we have a monkey cat STL. We'll open up Prusa Slicer, if I can spell correctly. We're set up for the smaller printer, that's fine. Import, STL, Blender projects, monkey cat. There's our monkey cat. And now I know, so right now, just the way that Prusa has picked it up, it's going to be 106 millimeters tall. Again, in Blender, I'm working kind of arbitrarily. Maybe I actually wanted this to be 150, so I'll scale this up. Prusa Slicer can do that just fine. I'm going to hit slice. This is not going to be printable, but just so that you can see, detected print stability issues. But there is our monkey cat that, if it was printable, would take 50 minutes. And maybe with some supports or some thoughts about design, we could get this to work in clay, and you could have this at the art fair and make thousands of dollars. Any questions? I want to give people some time to work. I know we have printers running. It's probably ready to run the second batch at this point if you are willing to stay longer. I'm also happy to work with you if you have questions about Fusion, questions about Blender, questions about using the printers. But I'm going to stop the kind of lecture part and give us some time to work.